look what I've got. I've had 2 deliveries. I've got 2 of my designed circuit boards have arrived. I've got the power board and I've got the mouse adapter. Courtesy of Elecro. Not sponsored, I had to pay for them. But one thing I do love about Elecro, I ordered 10 of each of these. There's 13 of those. There's 11 of those. They're not really very good at counting, but they always seem to count high, which is good. So I always end up with a few extras. So yes, here's my power board. Looks pretty decent to me. And the mouse board. We'll see how that comes out. So now I guess it's time to do some building. Certainly I'm going to build the power board and test that up. The mouse one, no real hurry for. I've got to sort out the software for that yet. So I'm not going to build that one just yet. But I really want to get this power one tested. So through the magic of video effects, there we go. One board built. I wish they were all that easy to build. So now, and I've already tested this one and it gives all the right voltages, to see about fitting it to the Amiga and see if it actually operates. Now there's one area of concern with this that might give a problem, and that's the -12 volt. It uses a 12 kilohertz switching frequency, and in my initial testing I could see a few millivolts of 12 kilohertz switching noise in there. So I'm hoping that that doesn't come out on the audio. And the -12 volts is only used for the audio, so it's not going to be critical to the operation, but it would be annoying if there's a 12 kilohertz whine to it. So I might have to add a bit of extra filtering in there somewhere. So as I mentioned, the board here is designed to fit just in here and replace this choke and the original connector, which has already been taken off. So let's take out the old choke, disconnect all my old wires, and see if I can get this board connected and working. It'll be so much neater than all this tangle of rubbish. So my first job, I guess, is I'll just cut away all these old wires. They aren't needed anymore, or I sincerely hope not anyway. They can all go. I'm going to need to reroute the 5 volt connection for the video output. That's not a problem. But that lot is gone. Now I need to remove these old stubs of wire. For that I'll need my trusty tweezers and my soldering iron, of course, and my glasses, because I can't see what I'm doing. I'm getting too old. I'll put my glasses on to work. Okay, I'll see if I can do this just from the top by just heating. See if I can just do this just by heating the top of the pad and lifting it out. There, nice and easy. The ground one is a bit more tricky because of the thermal mass. It needs a bit more heating before it'll pull out. Half of it. Come on, melt. Come on. I might have to come back to that one. Okay, all that's left is this ground one. Let me just clean that up. What I'm going to do here is add a little extra solder to it. Sounds counterintuitive, that does, doesn't it? There's thermal mass because of the amount of metal, so I'm adding more metal. but the fresh solder just helps to wet it a bit and help the heat to flow better from the soldering iron. There we go. I want these to be nice and flat, so I'll just clean off that with the dry soldering iron. Now I've got to try and get this out. So we'll go from the other side, and I wish I had a proper soldering iron gun thing, but have you seen the prices of those these days? There's no way I can afford one of those, unless of course you guys are generous and throw one my way, but no, that's never going to happen. So I've got a soldering braid. I do have one of those horrible vacuum hand pump things, but they're horrible. I really don't like those. They just spray solder everywhere. I much prefer to use simple soldering braid and flux. It just works so much easier and cleaner. I mean, it's a bit more involved, but it does the job. Just suck the solder away using the braid. It takes a few applications, and keep trimming the braid off. After a little while of wicking, you start to see the hole appear around the pin, and that's when you know you're getting close. Let's do the other half now. Yeah, it's quite wasteful of braid, this. And it's not the cheapest stuff in the world, but it's what I have, it's what I'm used to using, and the method works for me. We're nearly done on the first pass of the second half. Trim the braid again. Worth buying decent desoldering braid, and I bought some cheap stuff once and it was absolutely useless. It was little more than just the copper shielding from coaxial cable, effectively. Just woven copper and nothing else much. This stuff at least has got a bit of flux in it already, which is nice. It just lets the solder wick its way right up the braid nicely as you're working. It's nice to see it just suck all the way up the braid while you're desoldering. Okay, got that one there as being a bit of a pain. Let's add a bit more flux to it and just heat it up. Yeah, that's clearing okay. I want a bit of clear. Right, we are getting close now. It's going to be hot. Got movement on any of those pins yet? Let's just apply a bit of force and just see if it'll break the seal there. This one's awkward because it's the ground, so there's a large thermal mass on it. Let's try force in the other direction for these pins. Ah, it's just not having it, is it? What I don't want to do is break the inductor, because If this doesn't work, I'll be wanting to put this inductor back in, but I may not have that choice. I might have to use my other method for this, at least initially, which involves basically undoing what I've already done, but using a low temperature paste. So now I just, if I can squeeze this out, put a big blob of paste on each one and melt it back in. Certainly on the ground one I want to do this. So what this then does is massively lower the melting point of the solder that's already in there and make it an awful lot easier to desolder by making it easier for the solder to melt. It also means that the solder stays molten for longer. Which is good when you want multiple pins to all be released at once. If they can all remain molten, then theoretically you should be able to get it to fall out easier. There you go. That's cool. Put pressure on the other way and hopefully that will, yep, that's popped through. Pressure on and melt, and that should, now this is getting hot. This ground one of course is the awkward one. Pop. What I really don't want to do though is break the pads on the other side. And there we go, choke removed. Now these 4 holes here are the ones where the new board is going to be connected, but I want to clean up the whole lot really. Let's just start off with a bit of flux and the soldering iron, and just basically just clean the solder. There we go, just tidies up the actual solder itself, and I can see what I'm doing then. Next, good old isopropyl alcohol and a toothbrush. Get all the old flux off, not just my flux, but flux from when the board was made as well, I think. Be quite vigorous with this scrubbing. The flux does get kind of crusty while you're working with it like that. Okay, now I'm going to turn the temperature down a bit on the iron now, because this has got low temperature paste in it, so it should be a lot easier to work with. I just need to empty these holes out now, so a bit of flux on each. Back to the trusty solder wick. And just suck the solder out. There we go. Now I'm going to do pretty much the same on this side of the board, just clean it up. A little bit of flux around here, just to clean these pads up a little. It's not that there's going to be any electrical connection to them, it's just I want the pads to be flat. so they don't get in the way. I've got some low temperature paste on, let's get this into view, on this section here so that it's meltable. That's better. Clean these up. And give them a quick going over with a bit of braid. I don't need to clear all the solder out, I just want it to be flatter and tidier. This is the ground one, isn't it? Might turn it up again for that one. Oh, that's pretty flat now already. I can get away with a bit of lumpiness, but just keep it tidy. Pride in your work and all that. As I always say, if a job's worth doing, it's worth paying me to do it for you. There we go. Bit of IPA and give it a scrub. Keep it clean. There we go. Now the real moment of truth is, does this board even fit in the space? And I wasn't really able to do much in the way of measurements of it because of all the components and things in the way. So it was very much a case of eyeballing it. And it looks like I might have got it just about right. That's looking pretty good. Did the holes line up? Even the holes seem to line up. That's not bad. So now I need to attach it. And that's going to be slightly trickier. What I'm actually going to use, if I can find my box, what I'm actually going to use is just the ordinary 0.1 inch pitch header, which of course is completely the wrong size. But in theory, hopefully, I can take a length of this, gravity, I can just take a length of this and remove every other pin. That should just leave, it's easier if I do it the other way, 4 pins, which hopefully should be the right spacing to fit into the board. But that's not how I'm going to mount it. Close, but not quite. How I'm actually going to mount it is like that. So that then protrudes through the whole thing. Hopefully. There we go. Then also gives me 4 quite handy little test points for power on the top there. So the first bit of soldering will be soldering this to here, whilst at the same time not getting too much of a bulge. So what I'm thinking, actually, I might do it the other way around. What I'm going to do is hold this in place with a bit of tape or something, and then solder the other side, then lever off the plastic and then solder down from the top. so that this remains as flush to the board as possible. But before I do any of that, one thing I do want to do is cover up all these connections so they don't short with any of these connections on the underside. And for that, I'm going to use Kapton tape. It's high temperature resistant, so it doesn't care about me soldering. It's electrically resistant. It's the ideal solution, really. But first I need to find my scissors. So I'm just going to put a layer of Kapton tape across all these connections, going right to the edge of the board. It's the same tape that you'll often find covering parts of components when they go for wave soldering or things like that, or along the edge of a component. It's the same tape actually that you find on the edge of the A500 here. That's Kapton tape along the edge there. So it's used during PCB manufacturing and all sorts of things because it's heat resistant, it's rugged enough, it's thin, it's unobtrusive, and it's ideal for this kind of situation where you just need this layer of protection. So that goes into there. This goes over the top. Everything gets held in place somehow. I'm thinking probably, because it's heat proof, another piece of Kapton tape will do the job. That's Kapton, K-A-P-T-O-N, not Captain. Kapton tape is one of the Avengers, I think, isn't he? So we'll just put a bit of tape over that. Hopefully it'll hold it in place enough whilst I flip it over and solder the pins in. At least just tack the pins in, if nothing else. Okay, let's see what we can do. There's our pins. Here's our solder. And let's just give them a quick blast of solder to hold them in. I can come back and redo them afterwards if I need to. But that should be enough. That might be enough completely. It'll certainly hold them in place. Whilst I then flip the board back over, peel off the Kapton tape. You see, this is not soldered down at all yet. I need a screwdriver to just gently lever the pins up, the plastic up rather, leaving the pins behind. Pop that off. Okay, I can take this Kapton away. And then we shall solder this down. There we go, that's straighter again. Let that cool for a moment. A little bit of isopropyl alcohol will help. And now I can put the plastic shroud back over. Gently push it into place. Come on, down you go. Come on. Oh, good tight fit. There we go. Oops. That's it soldered into place with the plastic back on, creating a nice set of test points. I'll just now trim off the excess Captain tape at the front here. There we go. Job done. Now to see if it actually works or not. Fingers crossed. Well, I have partial success with this. It's almost working. I just did something that I'm not proud of, but I'll own up to it. I took the 12 volts, which is to power the Amiga, and would you believe it, I accidentally plugged it in to the 5 volt input on the video adapter board. I mean, how stupid is that? It's not my fault. I mean, who uses a 9 volt, 12 volt barrel jack on a 5 volt device? It should be a USB input on it. Come off it, China. Wrong connector. Especially when the cable that you give to power it by is a USB cable with a barrel jack on the end. I mean, it's a stupid design, but that's no excuse. Plugging 12 volts into there, it's fatal. Fortunately, it's only been fatal, as far as I can tell, to the video board, which, I mean, that was cheap. It's neither here nor there. I'm just going to have to get another one. I need to rewire it anyway and mount it better, so I'm not that upset about it. I've still got the composite connection, which is monochrome, but it'll do for now. But it does, if I plug that into the right port, it does actually power up. I've got no Gotex or anything attached at the moment, so it's looking at the moment. There we go, Amiga Workbench. So it's operating, but I say a slight issue with it. I say slight issue. This is why it's partial success, and this is the bit that was giving me the most worry, basically, is the minus 12 volts. Let's get my multimeter in. And the minus 12 volts, this is why it's good to have these test points. Oh, I said there was an issue, and the issue seems to have disappeared. I don't know why. Maybe it was since I disconnected the dodgy video board that's now blown up. But the minus 12 volts originally was giving me 0.6 volts instead. But now that I come to measure it, to say that there's a problem with it, it's minus 11 volts. That's perfectly acceptable. So that little board appears to be working. I just need to reconnect it all back to all the rest of the hardware and try it out and see if it actually can cope with the demands of a running Amiga. Okay, so we're now wired back up. We've got the mouse connected, we've got my clicky joystick connected, we've got both Gotex, we've got the keyboard, we've got my monochrome composite video connection. Let's power on and see what happens. The Gotex are alive. We have a Workbench screen coming up. Release 1.3.3, version 3434. This is looking good. No backup clock, battery back clock found. That's because it's here. Gotex clicking away happily, or it would be clicking if it made any noise. Mouse moves. This mouse interface turned out really very good, actually. I was very impressed with how it came out. Such a simple bit of code, and yet it just works. It worked perfect first time. I was quite gobsmacked by it, really. There we go, into Workbench. That is, at least for the moment, working happily. So let's try. I choose different files for the Gotex. Yes, I know, you can expect that. And reboot. See what the sound is like. Ah, good point. Before I do that, I need to fit this, don't I? I need the extra memory for this demo. Let's see if it'll operate now. Is it going to boot? Yes. And is it going to start? Yes, and we have sound. That sounds okay actually, considering it's coming out through my little monitor here. The negative 12 volts is working perfectly. I'm happy with this little circuit now. Can't really see much on my monitor at the moment because I've got my desk lights on, so it's just drowning everything out. Enough of that. So there we have it, it's coming on. 2 steps forward and 1 step back. Nice little circuit board for the power now, much better than that tangle of wires. A shame I no longer have colour, but I was never really happy with how I wired that up. I mean, it was only temporary anyway. So I'm going to have to hit up Mr. Amazon for another one of those. That's a bit of a pain, but, well, I mean, I'm assuming it's died. It's not giving me any signal on the HDMI, so something certainly would have gone pop. But quite what, it's impossible to tell. If it's one of these chips, got no chance. So I might give it a bit of a probe around, see if I can get some more life out of it, but I'm not holding my breath. So, well, that's the way the cookie crumbles. I shall replace that. I shall also need to build up and program and test out the mouse interface and the kickstart interface when that arrives as well, which hopefully will be just a few days now. So check back in the next episode and I might have built the mouse one up. We'll see.